And the next session is a bunch of lightning talks, which are going to be run by Alice Allen. So take it
Yes.
away.
Oh, there she is, I guess.
Yes, that's right. So we have four
Okay.
um, four lightning talks, and the first one is by Susanna, who I hope has raised her hand and has been given permission to speak.
So my name is Susanna. I think many of you know about the SKA, a project to build the largest radio interferometer with thousands of antennas in Australia and Africa. This instrument will be able to produce around 600 petabytes of data products per year and deliver this data to a network of SKA regional centers. And in these centers, it will be where the astronomers analyze scientifically this data. So the SKA regional center will be the core of the SKA analysis of the SKA science. And for this reason, we think that we need to pay us in the Instituto de Astrofísica de Andalucía in Spain. We think that we need to pay a special attention to scientific reproducibility and open science. So in particular, we are developing a SRC prototype, leveraging the flexibility of the cloud computing that allow us to incorporate services and tools as long as we are identifying tools and services that are able to support open science and scientific reproducibility. One of these tools is a science gateway. In particular, we are members of the European project ESCAPE. We are contributing to develop a science platform for accessing data and tools of the astronomy and particle physics community. We are also identifying best practices to enable scientific reproducibility from 2 points of view. From the point of view of the astronomer who wants to reproduce and automatize their analysis from the beginning to the generation of the tables and plot of the paper, and also from the point of view of the SRC, of the SKA regional centers, or other science platforms in astronomy, which wants to provide the framework and the tools that are able to support open science. We have other activities. For example, we are analyzing how we can use provenance in order to support open science. We are also contributing to other working groups interested in Science Archive, like Wallaby, and also contributing in the team interested in radio inside of the...
Thank you.
Okay, thanks.
Thank you.
Sorry, I didn't see the timer.
Hi, do you hear me?
Yes.
Okay. Hi.
No.
New issue region catalog from the Califa survey and the software that we use to generate it. This catalog comprises information from around 26,000 individual regions, including the flux intensity and equivalent width of 51 emission lines in the optical spectral range and the properties of underlying stellar population. We use the semi-automatic script PyH2 Explorer for the extraction and subtraction of H2 regions. So we know that the H2 regions are structured with strong emission lines that are clearly above the continuum emission. Therefore, we developed PH2 Explorer to identify clumpy structure with a high emission from an emission line map, for example, from a H-alpha emission map. To identify clumpy structure from an emission map, PyH2 Explorer needs several parameters to define clumpy structure, like a minimum flux limit to identify a peak emission pixel. Also, some input parameters determine the relationship between the peak emission pixel and the other pixel that define a clumpy structure, like the distance to the peak emission to the peak emission pixel. So the output of PyH2 Explorer is a segmentation map where each clumpy structure have a unique ID, and the complementary map where all clumpy structure are masked is provided as well. PyH2 Explorer has been tested on Califa and Manga data, and currently a new version for high spatial resolution data like Muse is under development. And if you are interested in PyH2 Explorer or the H2 region catalog, you found the links to the corresponding website in my poster, or send me a message in Discord. So that's it. Thank you.
Okay, you've got 20 more seconds if you'd like to say anything else.
Okay. Well, the last figure in my poster is the BPT diagram for this issue region. So with this sample, we define a new demarcation line for the BPT diagrams. So that is very interesting too, because we define, we define we identify the clump structure with the definition of H2 region. So look my poster, actually, for more information.
Thank you.
Thank you.
Somebody's hand is raised, I hope.
Yeah.
Thank you.
Am I audible?
Yes.
Okay, thank you. Hi, everyone. I'm Athanasius Ramaila from the South African Radio Astronomy Observatory. So at Sarao, we work on this project called CAN. So CAN is a set of astronomical packages or softwares that are released for Ubuntu operating systems. Currently, we have CAN 6 available, and the upcoming CAN is CAN 7. So basically, this is to alleviate the problem that many astronomers are facing in terms of software installation. So we package these softwares and publish them as Debian packages, and astronomers can easily install them. So that most of the time isn't focused on this software setup or pipeline setups, so that most of the time should be focused on doing real science. So this set of software tools are available also in containers for users who are not using Ubuntu system, so they can easily access them through the containers. And also, if you want to interact with us, you can go through the GitHub page. You can open an issue there, and then that will enable you to communicate with us. You can ask questions, and as well, you can contribute. So not to say much, but if you're interested in this open source packages, feel free to contact me or drop me an email or visit the website of CAN.
Thank you.
Yeah.
Yeah, you've got 10 more seconds if you want to say anything else.
10 more seconds. I can just wish myself a happy birthday.
Happy birthday.
Thank you.
All right. And then last but not least is Rosa. And let me find out what happened to hers, but go ahead and start and I will figure out what's going on here.
Okay, so I have a poster talking about improvements in our practices to support the development of astronomical software at STSCI. And as you know, as STSCI, we support several missions. So we have been able to leverage our experience managing and supporting the development of the calibration pipeline for HST to improve on JWST processes and enhance the collaboration between developers and scientists that work in this mission. So in the poster, I show how we work with Hubble and the limitations that it has, meaning that HST has a pipeline for each of the instruments, and therefore the groups work independently. And I'll also show how this contrasts with the way that we work in JWST. The development teams and the scientists were able to come up with a combined single pipeline for all the JWST instruments, and also added the benefit from adopting a programming language that was familiar for the astronomical community, which has enhanced the collaboration between these two teams. And also, in particular, I focus about the importance for us to establish and define a process that keeps this level of collaboration going through the whole process of the project, and also a process that worked for board groups and take into account the divergent responsibilities and priorities that these two groups might have that can break at any stage of the project. Finally, I list the most relevant steps that we have taken to make this more successful. That is regular communication regarding the changing of priorities between these two groups, also defining clear roles and responsibilities for the decision making and the prioritization of the work, even for the scientists collaborating in the project, and also adopting project management processes and tools across the science team and also the developer teams to communicate and manage work. And by implementing these few steps, we have already seen more collaboration and improved relationship between the scientists and engineers, and with this, the overall success of these projects. So I think it is very important to keep the collaboration going, to keeping growing, improving in these processes as we work in more projects at STSCI. So thank you.
Great, thank you. And that's it. Let's please thank our speakers, yay, for their lightning talks.